Can you talk about Big Bang and the inflation theory? My question to you on this topic is, how do we know by so much precision that the Big Bang has happened 13.8 billion years ago if we can't see by our powerful telescopes to the extent of 13.8 billion years, back in time? Then how do we know that it is that old? I mean, how did we come to that accurate prediction of that it is this much old?
Yes, that's a great question. Let me first say that it's not quite true that we can't observe. We can't observe back all the way to the Big Bang itself, but
okay.
may be familiar with the cosmic background radiation, which is pretty close. It's at a time fairly soon after the Big Bang. So we do, in fact, in my view, one of the greatest triumphs of modern astrophysics is the discovery of the cosmic background radiation. And studying the details of it is one of the elements to the basic answer to the question how we know so accurately about these early times in the universe. There are pretty good notions of what the universe was like a few milliseconds or microseconds or 10 to the minus some big number seconds after the Big Bang. And part of the example is that we trust that we know the laws of physics and how they go forward in time. Many of the laws of physics are predictive. If you know the current state, what happens in the future. But you can turn these laws around and run them backwards in time and decide what the universe must have been like early on so that the laws of physics evolved it to what we now see.
Right.
It's like taking a movie that you run backwards in time. And this movie is really a network of theoretical concepts and parameters determined from observations. But as near as we can tell, this backward movie makes sense and is coherent and doesn't have any fundamental problems or ambiguities or difficulties with explaining data, all the way back to a very, very short, like I say, even smaller than pico seconds from the beginning of the Big Bang. Inflation is going even farther back in time. I like to think of this as it's like a logical network of theory, observation,
right,
and human thought that is responsible for this really remarkable transformation of, over the last few decades, going from the nature of the universe and knowing whether it was created at a particular time or always existed, or all of that stuff was pure philosophical conjecture. But in a few decades, it's turned into a hard, solid science. And we do know these very solid things about the history of the universe. To me, that's got to be the most remarkable transformation of science. And it's hard to imagine it's common to say, well, Aristotle thought he was at the peak of science and that he was,
right.
And so you always think that you're in the golden era, but what more can we learn 100 years, 1,000 years from now, more fundamental than, the universe didn't always exist. It started 13.8 billion years ago. Here's how it started. Here are some pretty fine details of how it started and how it's evolved. But it's always surprising, and I bet we'll learn things that we haven't even dreamt of so far.
Right. Fantastic. I mean, sometimes I do think about this, that, we have done so much research and found out, almost everything about Big Bang. Einstein stated it that, the universe is expanding. And then, if we go back to that time, then there was that second when the Big Bang actually happened. But then my curious mind asks me, so what happened before that second? How did that matter come to that place? I mean,
yes,
yeah, nobody knows it, to be fair to everybody, but how amazing is that how did that happen, that point from which everything emerged was actually placed there, or actually was there? How? So yeah.
Right. Yes. Well, that's a fascinating question. I guess I have two things to say about it. One is
Sure.
maybe positive. You're familiar with the concept of kinetic energy and potential energy. There are two kinds of energy. And if you set out to calculate the total energy of the universe, including kinetic energy, energy through mass, E equals mc squared, you
Right.
add up that, and you add up the potential energy of the universe. If you make the best estimate that you can of the sum of all the forms of energy we know about, the net result is zero. That sounds impossible, but
Exactly.
potential energy is negative, and so in a real solid physics, no holds barred sense, the total energy content of the universe is zero, approximately, but maybe it's exactly zero, and so maybe that's part of the explanation of how something came out of nothing. Maybe, I mean, the answer being maybe what we think of as something is really nothing masquerading as something through. And there are similar concepts in quantum mechanics with the
Right.
spontaneous creation of positron-electron pairs, which spontaneously generate themselves out of nothing and then very quickly annihilate each other and return back to the so-called vacuum. It's not a totally satisfactory answer because, I mean, you just use the terms quantum fluctuation and random fluctuation and equal energies in the positive and negative sense, but those are just words. Is there something behind it? And again, using the practical, pragmatic, can you test it viewpoint, it's essentially an unanswerable question. Is there an origin? Is there a story that you can tell before inflation, before the Big Bang? With our current knowledge, we have no information, so we can't say anything about it.
Absolutely. Absolutely. But I'm really hopeful, Jeff, that, if we go like 500 years ago, we thought that the sun is revolving around the earth. And there were so many theories that, today science had proved it, which 500 years ago seemed like absolutely impossible, right? So I'm just thinking that maybe in 500 years to 1,000 years or maybe more, we might be able to find the reason of that as well. Like you said, why did that happen and what was the reason behind it?
Yes, to rephrase what you said, I think anything's possible. And to say it would never happen it's always wrong. Whenever you make a statement, something won't happen or can't happen.
Right.
Actually, when I was a graduate student, the concept of neutron stars was in the same boat.
Mm-hmm.
They were idealized physical things that the theoretical physicists could understand what a neutron star would be like if it existed, but the most thought was nature never could produce something as dense as a neutron star or even a black hole. And so people were saying they could exist, but they don't. We'll never see them. And that was wrong.
Right.